Hello class, welcome to Geometry Lesson 4.2, which is all about isosceles and equilateral triangles. By the end of this lesson, you should be able to apply theorems about isosceles and equilateral triangles to solve problems. So let's start with theorem 4.1. We have the theorem, also we have its converse right here, okay? So our theorem is if segment AB is congruent to segment BC, then angle ACB is congruent to angle BAC. So if you have a triangle where you have two legs that are congruent, it's isosceles, and that means that the two angles that are not formed by those legs, so I would say the angle that is formed by those legs would be right here, right? It looks like an angle formed by those blue lines, so don't include that one. It's the other two angles, so in this case, angle A and angle C. Those are also congruent. And then its converse is the opposite of that. If I give you a triangle and I say that I have congruent angles like this, that means my two sides, the two legs, are congruent as well, okay? So we have the theorem and then we have its converse. All right, so example 1, use the isosceles triangle theorem. So we have an architect is designing a community park between North 1st Street and South 1st Street. The pathways on either side of the pool will be equal in length. Okay, so that means if I draw this, here's my North 1st Street. That is going to be congruent to the South 1st Street. All right, so that's the information I have so far, and will provide effective access and circulation around the pool. So that means that I have to have another sign. To protect the landscaping and to minimize erosion, the architect will place a triangular section of triangular cobblestones at the corners along Park Plaza. What angle measure should the architect specify for the corners in her design? So you have the picture that was given to you in the book, and we have D, E, F. And then if we look at the picture, you can see that it tells us that this is 50. Okay, so that's 50. And we want to know what the other two angles are. If I have two congruent sides using that theorem from the last slide, I know that the two angles not formed by those two legs are congruent as well. So that means I'm going to use the total number of degrees in the triangle, so 180. So I'm going to say 180 equals 50, the angle that we know, plus x, right? Because those two angles have to be congruent. Or 180 equals 50 plus 2x. Subtract 50 from both sides. I have 130 equals 2x. And 130 divided by 2 is going to be 130 divided by 2, yes, is 65. Sorry, it's early and I'm questioning my mental math. So x equals 65 degrees. So the angle measure should be 65 degrees. All right, so now I want you to find the value of x in this triangle. Good luck. All right, hopefully you set up an equation that looks something like my top line of work there and then worked your way down to x equaling 23. If you have a question about that, please be sure to reach out for some help. All right, let's look at example 2 where we use the converse of the isosceles triangle theorem. So in the regular theorem that we just used, we were given the angle measures and we were solving for angle measures. Now we have side lengths and we're solving for side lengths. So converse has to do with solving for side lengths. All right, so we know it's an isosceles triangle because we have two angles that are congruent. And if those two angles are congruent, then these two sides have to be congruent. So that means that I can set up an equation. I can say x plus 20 And if they're congruent, I know that they are also equal. Equals 8x divided by 3. Okay, and I'm going to solve that equation. So right now, I have a fraction and I want to get rid of it, so I'm going to times by 3 on both sides. And if I'm multiplying by 3, I have to remember to multiply everything by 3. So I have 3x plus 60 equals 8x. Now, I'm going to subtract 3x from both sides. I have 60 equals 5x. And if I divide 60 by 5, I end up with 12 for the value of x. But that's not what it's asking. What are the lengths of all three sides? So if I plug 12 in here, I have 12 plus 20. That would be 32. If I did 8 times 12 and divide by 3, I also get 32. But here's a little trick. Isosceles triangle, you know those two sides are congruent anyways, so you don't have to do that work. If you trust that you've solved it correctly, you can do that. This could also be a good way to check your work. If you plug in the number into both and get different answers, chances are your x value is wrong. Now if I plug 12 into the last side and I do 6 times 12 and then minus 12, I end up at 60 for this side length. So I have side lengths 32, 32, and 60. All right, why don't you try to solve for the value of x this time? Good luck. All right, hopefully for this one you set 8x minus 1 equal to 4x plus 5 and solved it to get x to equal 3 halves. Now, using that x equals 3 halves or 1.5, I want you to solve for the 3 side lengths. Good luck. Hopefully the 3 side lengths you got were 11, 11, and 14. If not, please be sure to reach out for some help. All right, now let's talk about another theorem. It has to do with perpendicular. So remember, perpendicular means 90 degrees, and bisector means to cut in half. So it means that we have a line that is cutting something in half, and that line meets another line at a 90-degree angle. Okay, so our theorem says if a line or line segment bisects, cuts in half, the vertex angle. So if we look at this first thing, we have a vertex angle. We have something that's cutting it in half. You can tell because they put those lines there, the congruency symbol. So if a line or line segment bisects the vertex angle of an isosceles triangle, then it is also the perpendicular bisector of the opposite side. So if these two angles are congruent, that means that it's going to meet the next line at a 90-degree angle, and that it's going to cut this whole segment in half. Okay, so if I said this is 4, that means this is also 4 now. Or if I said this whole segment is 8, what would this part right here be? You would say 4. Okay, you can use that relationship. Then you can see, here's the drawing of what it would look like. They gave you the right angle and they gave you the 2 lines. Oop, too far. All right, so we want to use perpendicular bisectors to solve problems. We have a prefabricated house is delivered to a foundation in 2 symmetric halves that are assembled on site. Along the planned route to the site, the truck must pass under a bridge that has a clearance height of 17 feet. Should the trucker plan a different route for delivering the house? Explain. So we have our picture, and we have a simplified version of the picture, and we want to figure out whether the house is going to be too tall to go under a 17-foot bridge. So I'm just going to write 17-foot bridge here. Okay, so we want to figure out how high is this. Now if we look, if we have a perpendicular bisector in our isosceles triangle, remember perpendicular, we have a 90 degree now. And when we have a 90 degree, we have a special type of triangle. We have a right triangle. And the way we can solve that right triangle is using what theorem? Hopefully you're saying Pythagorean theorem at your screen right now. Although it is weird to talk to your screen, I applaud you for doing so if you're someone that did. All right, now we have A, B, and remember, C is always the side that does not touch the right angle. So I have h squared plus 14 squared equals 16 squared. So 14 squared is 196. 16 squared is 256. And I still have an h squared. So if I keep solving, I can say h squared equals 256 minus 196 is 60. And to undo a square, we take the square root. And normally we say plus or minus, but since we're talking about distance, we can't have a negative, so it has to be the positive form of that number. So what is the square root of 60? The square root of 60 is 7.74, or 75, sorry. So that is the height of the house. And if we try to figure out the height of the entire house, so that's just the roof part, right? So that was 7.75. So here I have 7.75, and that just covers this distance. But then I also have this distance of the house, which is 10 feet. So if I do 10 plus 17 or plus 7.75, the total height of the house is going to be 17.75, which is greater than 17 feet, that 17-foot clearance. So that means that the trucker must plan a different route to deliver this house. It cannot go under that bridge. Okay, so you guys are going to start using the Pythagorean theorem again. And make sure that even once you solve for your variable, make sure there's not another step, especially in those word problems, okay? Now, why don't you use the perpendicular bisectors to solve the problems? First, let's just focus on what is the measure of angle RSQ. Hopefully for the measure of angle RSQ, you solved using the number of degrees in a triangle, which was 180. You said 180 equals 31 plus 31 plus x. Or you could have said 2x because you saw that it was cut in half. RSQ is just half of it. I chose to solve for the entire angle first. So I got that entire angle is 118. And then since RSQ is only this half of it, I cut that 118 in half to get 59 degrees. Now, I want you to look at the picture and figure out what is PR. Hopefully you looked at this picture and realized with the perpendicular bisector that these two line segments are congruent to each other. So if this is 4, this also has to be 4. And we are looking for this entire distance, so I add them together and I get PR equals 8. If you have questions, please be sure to ask. All right, now let's talk about equilateral triangles. This will be the last triangle that we talk about this section. So an equilateral triangle is equiangular. So that means if I do 180 divided by 3, I get 60. So in an equilateral triangle, you have 3 60-degree angles, and the 3 sides are equilateral. Okay? So if you are given a triangle where all 3 angles are, it shows that all 3 angles are congruent, that means all 3 sides are congruent. On the flip side, if I show you that all 3 sides are congruent, then you can assume that all 3 angles are also congruent. So let's find some angle measures in isosceles and equilateral triangles. So if we start putting these triangles together as a single picture, how do we solve? So if the measure of angle CBD, so we have this right here, is 130 degrees, what is BAD? So then I want to know what this one is. Okay, So if I look, I know this entire thing is 130. I have an equilateral triangle here, an isosceles triangle here. So if I think about this, that 130 degrees, I know that this has to be 60 because it's part of the equilateral triangle. So 60 plus what gives me 130? 60 plus 70. So that angle is 70. And now I can use this 70 to solve for my two, these are called base angles. I don't think I said that earlier. In an isosceles triangle, the angles that touch the base of the triangle, the side that is not congruent to any other side, those angles are called base angles. So I have 180 equals 70 plus 2x, or 110 equals 2x, or x equals 55. So if x equals 55, that was this angle right there, I can say the measure of angle BAD equals 55. Let's try another one. If I want to try to figure out the measure of angle U, so that is right there. You can see I don't have any equilateral triangles. I have two different isosceles triangles. So first, since the only angle I have is 72, I have to solve for these angles. So if I do 180 minus or equals 72 plus 2x, 180 minus 72 is going to give me 108 equals 2x divided by 2, and I'm left with x equals 54. So I know that this angle measure right here is 54, this angle measure right here is 54. And then my next step, I need to figure out what this angle is so I can solve for my last two angles, or just angle U, right? So I have if I look at the 54, it is supplementary to the angle right here, and angle TVU. So if I do 180 minus 54, I end up with my angle TVU, which is 126. So this is 126. My last step is going to be to solve for that other angle. So 180 equals 126 plus 2x. So now I'm just looking at this triangle. 180 equals 126 plus 2x. 180 minus 126 is going to give us 54. And if I divide by 2, I have 27. So x equals 27, and x in this problem represented angle U, so I'm going to rewrite that to be angle U equals 27 degrees. All right, now why don't you try to find the measure of angle PNO. Good luck. Hopefully for PNO, you realized that I gave you an equilateral triangle on the left. So all of those angles are going to be 60. And then you saw we have some supplementary angles. So 180 minus 60 gives me 120. So PNO is 120 degrees. And then why don't you solve for angle NOP? Hopefully you used the same method and you got 30 for both of those base angles. So angle NOP equals 30 degrees. Here is your concept summary for those of you that like to take screenshots. It has everything that we've talked about today. And if you have any questions, please be sure to reach out for some help, and I'm happy to assist you. Have a great day.